Parallel lines have the same gradient. It is a sad story of two lines that have so much in common but will never meet. Are these straight lines parallel? Let's have a look. Y equals mx plus c. Now, as we know, parallel lines have the same gradient. As they are both in this format, we can very easily see that m in each line is equal to 2. Therefore, we have parallel lines. All right, are these straight lines parallel? The first one, we need to transpose. So we want this in the format y equals mx plus c. So in order to get that, I need to go 2y. See how this is minus 4x? The opposite of that is plus 4x. So 2y equals 8 plus 4x. That's what we need to do here. As I write this in, there we go. The final step, we've got to get y on its own. So if this is multiplied by 2, the opposite is to divide each side by 2. So I'll show that now. And of course, because these are both divisible by 2, I can end up with whole numbers. So these cancel out, and now I'm left with y equals, I may as well put this in the order mx plus c, so 4x divided by 2 is 2x, and 8 divided by 2 is 4. So this will become y equals 2x plus 4. Okay. Now we check the gradients. The gradient of this equation is 2. The gradient of this equation is 2. Therefore, they are parallel. Okay, so this one is a typical test question. We want to find the equation of a line that is parallel to y equals 4x plus 3 and passes through -2, 5. Okay, well, the first thing we want to observe here is that we have a set of coordinates. They are x and y. All right. So we know the parallel lines have the same gradient. Therefore, I know that y must equal -4x, because that's the same gradient as the line given in the question, plus c. The objective of this problem is to work out what c is so you can get your equation. So I know y is 5, and I know x, I know it's very badly drawn, but that is x, is equal to -2. So -4 times -2 plus c. Now I've got to give this equation a bit of a tidy up so I can work out what c equals. 5 is equal to -4 times -2 is positive 8. Remember, a negative times a negative is a positive, plus c. So in order to work out what c equals, I have to bring the 8 across and minus it. So that means c, when I work out 5 take away 8, is -3. Therefore, the equation of the parallel line must be y equals -4x, same gradient as the original equation, minus 3. Okay, the perpendicular lines form 90-degree angles, so think of the letter T. There'll be right angles in that. So when you multiply the gradients of each of these lines, they will make -1 if they are, in fact, perpendicular. Okay, are these straight lines perpendicular? Well, they're in the right format, y equals mx plus c. So if I multiply the gradients together, if I go 2 times -half, I should end up with -1. If that is the case, we have perpendicular lines. So 2 times -half is, in fact, -1. We have perpendicular lines. Okay, are these straight lines perpendicular? Well, the first one is on the format we like. Let's get that into y equals mx plus c format. So I have negative 3y. I'm going to minus 9x when I bring it across. So I'm just going to put it at the front there so I can get it y equals mx plus c quite easily. So I'm just going to bring the 9x and make it the opposite on the other side, which is what I'm showing now, plus 12. That is a positive 12 there. All right, I'm one step away from getting y equals. I need to do the opposite of times negative 3, which is divide negative 3. I've got to do that to each side of the equation, as shown here. There we go. These negative 3's will cancel out, and now I'm left with y equals negative 9x divided by negative 3 is 3x. 12 divided by negative 3 is negative 4. So the way to work out if these are perpendicular are to multiply the two equations' gradients together and see if it equals negative 1. Well, this one I've got 3 times the gradient of the second equation is a third. 3 times a third equals positive 1. We are after negative 1. Therefore, these ones are not perpendicular. A practical problem. Find the equation of a line that is perpendicular to y equals 6x plus 3 and passes through 12, 5. Okay, first of all, I know these coordinates here must be x and y. I'll label that. The equation, the first one is shown in the nice format of y equals mx plus c, so no rearranging here. Now, what we want to do here is work out the perpendicular line's gradient. Very quick way with a whole number is to put negative 1 over the gradient itself. So the first gradient there is 6. So the perpendicular line will have a gradient of negative 1/6. Now let's plug that into the equation y equals mx plus c. So y will equal negative 1/6 of x plus c. I know what x and y are, so I'll plug them into the equation. So 5 is equal to negative 1/6 times 12. I've deliberately chosen 12 for this to get a nice whole number. Plus c. Okay, so plus c. Let me just get that down. Right. So negative 1/6 of 12. 12 divided by 6 is 2. So this must be negative 2 because it is a negative value at the front. Plus c. Now the last step, we just need to add 2 to this side, the opposite of the minus 2. That is out. C will equal 7. Once that's all worked out, C will equal 5 plus 2, which is 7. And the final step is stating the equation of the perpendicular line. So keep the gradient that we started with, negative 1/6 of x plus 7. There is the perpendicular line. All right. This one says find the equation of a line that is perpendicular to 4y plus x minus 4 and passes through 3, negative 8. All right, well, the first thing is this equation is not in the y equals mx plus c format, which we want. 2 steps to get there. I'm going to minus x across the other side. So this is going to be 4y equals minus x. So that's across there now. Minus 4. And of course, the other thing I should do is label the coordinate x and y. Okay. So one more step to get y equals, I need to divide both sides by 4. So I'm going to end up with these 4's cancelling out. Y equals. Now it says negative x over 4, which is the same as negative 1/4 of x. and then that'll become minus 1. All right. Now, the perpendicular line can be worked out by going -1 divided by -1/4. -1/4. Make that negative sign a bit clearer. Once that's worked out, it's the same as -1 times -4. So that's going to become +4. So the gradient of the perpendicular line will equal +4 once that's worked out. So if you put that in the calc, -1 divided by -1/4, you end up with +4. So this equation is going to be y equals 4x plus c. And again, same process. We plug in the coordinates we have and try and work out c. So this one, -8 will equal 4 times 3, the x value is 3, plus c. Got to give that a bit of a tidy up. -8 is equal to 12 plus c. Opposite side, I've got a -12. Get rid of it there. C will equal -20. So the equation of the perpendicular line will be y equals 4x minus 20. There we go. And that's the perpendicular line for this equation. If you found this video helpful, don't forget to subscribe to Prime Maths 101. And I'm sure there'll be plenty more videos to come.